This channel, the DevOps Bucket. My name is Sai. So imagine you deployed a backend service in Kubernetes and also a front-end service. Okay, with there is one Kubernetes cluster. Here it is a front-end service and here it is a backend service. Front-end server should talk to the backend server and backend server should respond back to the front-end. Right. So your front-end server pod needs to talk with to the backend server. The IP for the backend service, you take that and you try to place it in your front-end code. But that is not possible because it's not a static IP, and so you didn't hardcode an IP address. So you just need a service name like backend-service to communicate with that particular backend server from frontend. Now pause for a second and ask yourself if this is a question. How does Kubernetes will convert this domain name to the IP address or the service name to the IP address? So this will done by the component called CoreDNS, which is present in your cluster. CoreDNS. Okay. So CoreDNS is one of the most important component in Kubernetes. So everyone will use it blindly because it comes along with the cluster installation, or you will install it before do your workload deployment. So today I will explain what is CoreDNS really and how it will work internally as well, and what actually happen when pod tries to communicate with another pod or a service in the cluster. By the end of this video, DNS inside Kubernetes will feel very logical and understandable concept. Let's start from the problem first that Kubernetes had to solve with this core DNS component. In Kubernetes, as you know, the pods are ephemeral in nature as per the pod IP addresses. So pods are temporary in nature. So they are ephemeral by default. They die and they restart. And whenever they do this lifecycle action, the IPs will change all the time. How you feel that your EC2 instance or any virtual machine will change its IP address, public IP address whenever it restarted. It restart, right? So like that, pods are also containers are also ephemeral in nature. So whenever they die or restart, the IP will change. Services also get a new endpoints when scaling happens. So Kubernetes cannot rely on the static IP addresses, but the application still need a stable way to communicate to the other pods or services within the cluster. Like front end need to communicate to the with the backend, and we don't like IP address because we cannot remember or we don't change every time whenever pod changes its IP address of its own. Applications also prefer the names which we will remember the service name or whatever the DNS name that we are using. So that is where core DNS or DNS comes in picture, and that is should require inside the cluster as a component. So CoreDNS is the DNS server for the Kubernetes cluster. So what is the CoreDNS? First of all, CoreDNS is a DNS server. That's it. It's a DNS server. Okay, not any other component. It's just a DNS server for the Kubernetes cluster. Whenever pod asks a question like, hey, what is the IP address of my service name? And it will then check its entries and identify what is the IP associated with that service name domain. Then it will reply us like or the pod that with the particular IP address that currently hold by this pod. So without CoreDNS, Kubernetes networking simply doesn't know work the way that we expect. Like whenever we ask the service name, it doesn't return anything until we install or we use the CoreDNS component. It's a acts as a DNS server. Now let's understand what this CoreDNS is actually do internally. CoreDNS, as I said, it's a DNS server that was written in a Go language because Kubernetes components are built in the Go programming language. In a cloud native, it is like a cloud native, lightweight, and plugin based system. If we can say in a single line. Earlier, Kubernetes used something called kube-dns. Okay, kube-dns itself is called a kube-dns. Okay, but CoreDNS is replaced because CoreDNS is a faster and more flexible and easier to extend. Today, CoreDNS run as a deployment in a kube system namespace. So where it will run? It will run as a pod only by the deployment controller. Okay, it is like a deployment which will run in the kube system namespace. Kube-system namespace only. Okay. If you see kubectl get pods -n kube system, you can able to see the CoreDNS pods are running. Okay, so usually with the multiple replicas for high availability as well, because this deployment should contain multiple replica count to adjust the availability of your core DNS server inside the cluster. So yes, core DNS itself run as a pod inside the cluster, as I said. Now let's talk about what happens in the real life when pod makes a DNS request to the other pod. Okay, so a pod want to connect to a service called backend.service, backend-service, let's say backend-service. So my front end pod is communicating to this domain backend-service. So inside that pod, so this backend service pod, this is a service name, right? This service name will hold some backend pods, right? Pod 1, pod 2, let's say, right? It's a grouping of pods. So this is a front end service, right? This is a front end service and it's trying to contact with the backend service, right? This backend service contains the backend pods, pod 1, pod 2. So from where you are originating the request, from front end pod, this is the front end service and this is the these are the front end pods. So front end pods, you are originating the request to the backend DNS name. So here the flow will be, the pods of this will contain a file called /etc/resolve-conf. So the file called resolve.conf will be available in the /etc folder of every system. So what it will contain? It will contain the DNS server details of a particular server that you are using to translate this domain to the IP address. So currently in our case, it's the CoreDNS. So whenever any request originating from this section, first it will check in itself at /etc resolve.conf file where we have the core DNS service IP, right? So this file tells the pod, if you want to resolve a hostname, send that request to a particular server. So whenever a request comes to this with a particular name, it will check in this file. It will say that whenever the request comes to me, just share that request, just sends that request to a particular server. Which server here? In our case, it's a CoreDNS server. CoreDNS server. So whenever a request coming or you want to resolve a host name, send the request to the DNS server. The DNS server IP is the cluster IP of the CoreDNS service. Okay, so whatever we are writing here is the CoreDNS service. Okay, so CoreDNS, as I said, CoreDNS will be deployed as a deployment, right? So this deployment will have a service that is called CoreDNS service. CoreDNS service. So whenever, or kube-dns service, okay, whenever you ask your pod to send the traffic, whenever send the resolution request to this CoreDNS server, it will go to the service. And this service will have the backend pods as its CoreDNS deployments. So the traffic will route like this. So whenever it will go to the resolve-conf and will identify the CoreDNS server, and then it will go to that CoreDNS service. That service will holds the backend pods as a CoreDNS deployment pods, and it will reach that particular thing to the CoreDNS deploy. So now CoreDNS will take that query, and now CoreDNS receives the request and start processing it using its a core file. So CoreDNS deployment, everything will contains one file called core file, is a configuration file of the CoreDNS. This file shows how this DNS query should handle. Inside the core file, there is a Kubernetes plugin enabled. This plugin also allows CoreDNS to talk directly to the Kubernetes API server. CoreDNS does not store service IPs permanently. Instead, it watches the Kubernetes API. Whenever a service is created, deleted or updated, CoreDNS already knows about it because it will always contact with the Kubernetes API server to get the details. Whenever a service is created or deleted, updated, so this is how it will know by the CoreDNS. So when a DNS request comes in for a Kubernetes service, CoreDNS asks itself, is this a Kubernetes service name? If yes, then it fetches the service details from its cache, which is synced with the API server. Then it returns the cluster IP or pod IP, whatever that hostname contains. All of this happens in a milliseconds, as you know. Now let's talk about the DNS naming inside the Kubernetes. Every single service gets a fully qualified domain. This is called a service discovery concept in the Kubernetes. Like whenever you have created one deployment and then created a service with a cluster IP service, let's say, and then the service will hold a DNS name that is called a service discovery. To discover that particular service within the cluster, we will use this concept called a service discovery. So the name will be like this: service name, service hyphen name dot namespace dot svc dot cluster dot local. Okay, this is the name. Let's say we are talking about backend service, so it will be like backend hyphen service dot namespace should be like let's say your namespace is app, so app dot svc dot cluster dot local is the common wording, okay, to identify it's within the cluster and the local. Okay, so but Kubernetes is smart. If your pod is already inside the same namespace, you can use simply like backend service, that's it. If let's say your front-end pod is different namespace and back-end pod is different namespace, then you need to use this entire service discovery DNS name. If your front-end and back-end pods are on the same namespace, then you can just go with the back-end service. The remaining part will be handled by the Kubernetes, which will be having that in your etc resolve conf file, which will be added. Like whatever request is coming, please add this to my requested domain and try in the CoreDNS server to identify this contains any IP entry in you or not. And DNS search path will automatically complete the rest, as I said, right? That's why in most applications just use a short service names, because they both in the same will be in the same namespace. Now let's understand something very important. CoreDNS does not only resolve services; it can also resolve pod DNS if enabled. Okay, and then external domains like google.com, custom internal domains, cloud provider DNS entries. Okay, I will repeat it. So it will work with the pod DNS if enabled, and external domains like google.com or amazon.com, etc., and custom internal domains and cloud provider DNS entries as well. How? Because CoreDNS is a plugin based, as I said. For example, if a DNS query is not related to the Kubernetes, CoreDNS forwards it to an upstream DNS server like a node DNS or maybe VPC DNS or public DNS. So CoreDNS becomes a central DNS brain of the EKS of the Kubernetes cluster or EKS cluster or AKS, whatever cluster you're using. It's a core brain for your DNS. So whenever a request is coming to your pod to like to a service name, it will go to your DNS server. This DNS server will identify that it's a cluster domain or not. If it's within the cluster, it will resolve automatically. If not, then it will transfer that request to its upstream DNS servers. Okay, so let me quickly give you an example how it works at a EKS point of view. Let's say this is your EKS cluster and this is your node. This is your node. Okay, inside this node, you have a pods, pod 1 and pod 2. Let's say pod 1 should communicate with the pod 2. What you will do is you will need to use a pod 2 service name in your pod 1 code, so that it will directly connect to that particular thing, because both can be in that same namespace. Otherwise you can mention the fully qualified name of your service, like service name dot namespace dot svc dot cluster dot local. That's fine, that's for within the cluster. But if the request that you would like to send it outside world, okay, let's say if any let's remember this point. Okay, if you send or if you initiate any DNS request within the cluster, first it will go to your DNS server like CoreDNS. First it will identify that it's a whether it's a service, internal service of Kubernetes or not. If not, then it will check the CoreDNS server's etc resolve conf file. Okay, and identifies is there any upstream server configured. Yes, it will be configured with an upstream server in EKS point of view, that is like VPC DNS resolver, which will be a common resolution point for other configurations other than the cluster's internal DNS. Okay, then you will go through this particular DNS server and handles the DNS request. So how the request flow? First, pod 1 will communicate to your pod 2, need to communicate with your pod 2. First it will check its internal etc resolve conf and send it etc resolve conf and send it to the CoreDNS service. That CoreDNS service will check the CoreDNS backend pods and like CoreDNS pods which are connected with the service, and then it comes to the CoreDNS pods. Okay, CoreDNS pods, and it will check its resolve conf and the DNS servers it have. If it's internal server, then it's okay. Internal service, it's okay. Then it will resolve it and send it to this pod 1, the IP address of the particular other service that you want to try. If it's an external domain, what it will do, it will check its internal etc resolve conf. Then it will go to the that server directly. Substream server, that is a VPC DNS resolver. Actually, I said right, traffic routing and load balancing is done by kube-proxy, IP tables or IPVS mode service abstraction. CoreDNS only answers to the whatever the IP address you asked for a particular domain. If it knows, it will gives you, otherwise it will send it to the transfer it to the upstream server. That's it. Now how traffic flows, as I explained you, this is the traffic flow point. CoreDNS runs multiple replicas. This is a cache plugin enabled. So there is also cache plugin, as I said. So separate or repeated DNS queries do not hit the Kubernetes API server like continuously. It will check the cache part only. It's extremely important at scale. Without caching, the API server would collapse under the DNS workload. This is why misconfigured CoreDNS can bring down your normal cluster as well. Like normal kube-adm cluster, what you install, you should maintain that. So if CoreDNS is down, The pods cannot resolve service names, external APIs doesn't work, application fails mysteriously, health checks are also started failing. So if you face any timeouts inside the cluster application to connect with another application outside world or within the cluster, please check the CoreDNS logs. Okay, and also implement scaling by checking the metrics of it, how much CPU and memory it is consuming. And finally, like if your interviewer asks how does service discovery works in Kubernetes, and you answer with the clarity about CoreDNS, you will immediately stand out. So now the final takeaway is CoreDNS is not just a some DNS thing. It's a foundation of service discovery in Kubernetes. It translates name to the IP address. It watches the API server. It integrates with the Kubernetes deeply, and it also enables microservices to talk reliably, and it make dynamic infrastructure usable. So if Kubernetes is the operating system of the cloud, the core DNS will be its server. Like it's a DNS server. It's like a phone book. Like how you have added your name and then mapped with the phone number, like that it will map your domain with your IP if it is within the cluster. Otherwise it will go to your its upstream server. That is it for this video. If you understand this video, please like this, and if you are watching this channel for the first time, please subscribe to the channel, and please comment down below whatever the topics that you want to understand and want to see in a practical as well. Thanks for watching.